Well, in this session, we are going to talk about conditional probability. Before talking about conditional probability, let's take an example to understand it. The conditional probability of event A given B is, the notation is PA given B. That means the probability of occurrence of event A when B has, under the condition that the B has already occurred. Means it is known in advance that event B has taken place, then what is the probability that the event A will occur? This is what we call conditional probability. Probability of event A given the event B has already taken place, B has already occurred. Let's try to understand this with a simple example. Let's take the case of throwing a die. If we throw a die, if we throw a die, the sample space, the set of all the possible outcomes is given as either 1, 2, 3, 4, 5 or 6 will appear on the uppermost face of the die. So the sample space will contain these 6 points. Well, now if we define an event, suppose I define an event A, the event A is getting 2 on the uppermost face. This is the event A. Well, so what sample point are in favor of getting 2? This is the only sample point which is in favor of getting 2. This can happen in only this way, one way only. Well, so number of elements in A, number of sample points in A are 1, number of sample points in the sample space are 6. So probability of A will simply be given as number of elements in A, number of elements in S, that is number of outcomes in favor of the event A divided by the total number of outcomes. Here only one outcome is in the favor of A and there are total 6 outcomes. So the probability of A is 1 by 6. Suppose we are given a condition that some event B has already taken place. Suppose we define here, let B is the event of getting an even number on the uppermost face. Well, so this B will have, now B has already taken place. That means now our sample space is not S actually. Now our sample space is reduced. B has already taken place means we have got an even number, that means either 2 or 4 or 6 has appeared. B has already taken place. That means either 2 or 4 or 6 has appeared on the uppermost face. That means now our sample space is reduced. Now it has only 3 sample points. Now if we talk about probability of A given B, that means probability of A means getting 2. Probability of getting 2 when it is given that the number is even. Well, so now our sample space is reduced. We have got an even number. It is known. B has already taken place. That means there were only 3 possibilities. Either 2 has appeared for B, either 2 has appeared or 4 or 6 has appeared. Out of these, what are the chances of getting 2? Out of these outcomes, how many outcomes are in favor of the event A? That is getting 2, 1. 1 by 3. So here the probability of unconditional probability of getting 2 was 1 by 6, whereas the conditional probability, if B has occurred, then the chances are double because there are only 3 sample points. Now out of these 3, 1 is in our favor. Here there was 1 out of 6 and here the probability 1 out of 3. So this is what we call conditional probability. Let's take one more example. Well, now let's take the example of tossing 2 coins simultaneously. When 2 coins are tossed simultaneously, the sample space is given by both heads. First coin shows head and second tail, or first shows tail and second one tail shows head or both shows tail. We can see the number of sample points in the sample space. Total number of outcomes are 4. Suppose we define the event A as getting 2 heads. That is, both are heads. So only one sample point is here in the favor of this event A. So number of elements in A obviously are 1 here. Okay. Now, if we are known that the event B has already occurred, and we have the condition. We put restriction on this sample space that at least one head. B is the event that at least one head has appeared. So this will be considered. At least means from minimum to maximum. Minimum 1 has there. Okay, it has minimum 1, so it will be accepted. It has minimum 1, at least 1 head. So this is in the favor. This also has 1 head, so this will be included. But this do not have at least 1 head, so it is not in the favor of B. Now, our sample space. When we talk about probability of A given B, then our sample space is reduced to B. That means B has already taken place. So number of sample points here in B are 3. Out of these 3, which are in the favor of A? Yes, this one, HH, this one sample point is common to both. So this is, if B has already occurred, then the chances of A, that means there are 3 possible outcomes. Out of these 3, A can take place with this simple event. So this is 1 by 3. So now this is probability A given B. Now we'll try to develop a formula, a mathematical formulation for A given B. Well, to understand conditional probability, the formula for conditional probability, let's take help of Venn diagram. Suppose S is the sample space which includes n elements, and A is an event and B is another event. Suppose we are interested to find the probability of happening the event A when B has already taken place. That is the conditional probability of A when B has already taken place. Now, to find this, as we discussed, now our sample space will be reduced to B. That means we will be considering only those sample points now. To calculate this probability, we will consider only those sample points where B has occurred. That means this will be the, suppose number of elements in B is NB. So this will be simply number. The total number of outcomes, that is the reduced sample space. Now this event B, this will be considered as the sample space for this event A given B, because B has already happened. If B has already happened, now the chances that A will happen, obviously only B has happened, that means this has not happened, this has not happened. We will be considering only this. Out of this, A is happened here. This actually is A intersection B, this part. If B has already occurred, then the sample points which are in the favor of A are these. That is, suppose the number of elements in here is number of elements in A intersection B. So this is how we can define probability of A given B in terms of number of sample points. If I divide both the numerator and denominator by total number of outcomes, that is number of elements in sample space, total number of outcomes, both the numerator and denominator, I am dividing it by total number of sample space, then this relation comes in terms of probability. This actually is the probability of A intersection B. Probability of A intersection B. Number of elements in favor of A intersection B divided by total number of outcomes. And this is nothing but the probability of event B, number of elements favorable to B divided by total number of outcomes. So we can see the formula for probability A given B is probability of happening both the events together divided by the probability of that event which has already occurred. Suppose if I say the probability of A B given A. Suppose I am interested in probability of B given that A has already occurred, then what is the rule? Simply the probability of happening both these events together, that that is B intersection A, which can be written as A intersection B, divided by probability of that event which has already occurred, divided by probability of A. This is how it works. Suppose I am interested to know the probability of E given F has already occurred, then what I need to do is I'll find the probability of happening both the events together, that is probability of E intersection F, and this probability will be divided by the probability of that event which has already occurred. Here, one point must be noted that since we need to divide this by probability of B, here we must assign a condition that probability of B should not be 0, because if the denominator is 0, if there is no sample point in B, then no question arises, then this A given B will not be defined because we cannot divide something by 0. So that is what we can talk about conditional probability. Let's take some questions from NCERT textbook. The very first question here says we are given E and F are events such that probability of E. The very first question, let me take the first question of exercise 13.1. It says we are given the probability of E and probability of F. Also we are given probability of E intersection F. Exercise 13.1. We are given probability of E, that is nothing but 0.6, and probability of F. Probability of F is equal to 0.3. And also we are given probability of happening E and F together, that is E intersection F is equal to 0.2, and we are to find two things. Probability of E given F has already happened, and we are to find also probability of F given that E has already happened. So by definition, probability of E given F will obviously be probability of happening both the events together divided by probability of that event which has already occurred. So this is probability of E intersection F here is 0.2 divided by probability of F. Probability of is 0.3. So obviously this will be 2 by 8. Also we are to find probability F given E. So by definition, probability of F given E is equal to probability of F intersection E divided by probability of that event which has already occurred. The same will be in the denominator. So here probability of F intersection E is same as E intersection F. So this is 0.2. Now this time we are to divide it by probability of E, that is nothing but 0.6. 0.2 upon 0.6 is 2 by 6, that is 1 by 3. So this is how we can find the conditional probability of one event given that the other event has already occurred, if we know the probability of happening both together. Let's take the second question. It says compute probability of A given B if we are given the probability of A intersection B and probability of B. Simple formula based questions are there. Suppose this is a question number second. If I talk about, very simple it is, we are to compute. What we are to compute? Probability of A given that B has already occurred. If we are given probability of B actually 0.5 and probability of A intersection B is nothing but 0.3. Obviously, by definition, probability of A given B is nothing but the probability of happening both the events together divided by probability of that event which has already occurred. So this is A given A intersection B, 0.32 divided by probability of B, that is 0.5, that is 32 upon 50, nothing but 16 upon 25%. In this question, we are given that assume that each born child is equally likely to be a boy or girl. family has two children, well, if a family has two children, then what is the conditional probability that both are girls? Suppose we give this event, both are girls is denoted as A. What is the conditional probability of A given that first part youngest is girl? Suppose I name this event as B, then we have to find probability, conditional probability of A given that B has already occurred. Also we have to find, suppose I name this event as C, then also we have to find the conditional probability that both are girls given that at least one of them is a girl. Well, if the family has two children, then the first one is boy, B for boy, and second one is also boy. Or there may be first child is boy and the second child is girl. Or there may be a possibility that first child is girl and second one is boy, or both are girls, means first one is girl and the second one is girl. Let's define these events. This is the sample space because the family has two children, so two children can be both boys or both girls. The elder one is boy and younger one is girl, and the elder one is girl and the younger one is boy. These are the four possibilities. Well, here A, let A is the event that both are girls. Okay. Then the number of sample points, both are girls. Here both are not both are girls, not both are girls, not both are girls. Here both are girls. So this one sample point out of 4 is in favor. So probability of A is simply 1 out of these 4 sample points. Also B is defined as the youngest is girl. Suppose B is the event that the youngest is girl. Youngest means the one who is born at the second position. That will be young. This will be old and this will be young. This born first, then it is elder. This is born after this. So this will be the younger. The youngest is girl means the second one must be girl. This is here. Younger one is not girl. Yes. Here the younger one is girl. So this case will be considered G1, G2. See, here the younger one is boy, but here the younger one is girl. Younger means one who is born after this one. So second one will be the younger. So this is G1. Here you can see the youngest means the child born at the second position. The second child is girl. First child is not girl. First child is older child and second child is younger child. Well, so probability of B is equal to total number of outcomes in favor of B divided by total number of outcomes in sample space. Alright, now also here we have defined C for this part. At least one is a girl. At least one is a girl. Let's see. Here there is no girl. We will consider only those cases where at least one is a girl. So this sample point will not be in favor. This at least one is girl. Okay. This in this at least one is girl. And here both are girls means at least one is girl here. So this and this satisfies this condition. At least one is a girl. So B1, G2, G1, B2 and G1, G2. If I ask probability of C, probability of C will simply be 1 by 4. Now, let's see A intersection B and A intersection C, because we will need this by definition. If I need to find probability A given B, in that I will need probability of A intersection B divided by probability of B. So A intersection B. Now A intersection B. You have A. This is simply A. G1, G2. G1, G2. Intersection B. Here the event B. B1, G2, G1. B1, G2, G1. So here the common elements are, obviously there is one common element, that is G1, G2. So probability of A intersection B is one sample point is in favor of A intersection B and total number of sample points are 4. Also, probability we find A intersection C. A is simply G1, G2 intersection C. Well, C is this B1, G2, G1, B2. Let me write B1, G2, G1, B2 and G1, G2. So the common point, this is the only common point, G1, G2. So probability of A intersection C is equal to number of elements in A intersection C, that is 1, divided by total number of outcomes here. Now, by definition, probability of A given B is nothing but probability of happening both together divided by probability of B. Probability of happening A and B together is 1 by 4. So this is 1 by 4 divided by probability of B is 2 by 4. So 2 by 4, that is simply 4 will be cancelled by 4. That is 1 by 2. That is the answer to the first part. Probability of A, probability that both are girls given that the youngest is girl. Now for second part, given that at least one is girl, that is A given C. Probability of A intersection C divided by probability of C. Probability of A intersection C here is 1 by 4 divided by probability of C. C means at least one is girl. There were 3 cases in favor. This will favor